Imagine paying $15 million just to watch your luxury penthouse walls crack as the building sways 5 feet in the desert wind. A $1.4 billion glass needle, whipping through the sky while the engineering meant to save it is actively tearing it apart. This is the terrifying reality of Dubai's most dangerous luxury. Before we dive into the data, if you are new here, this channel covers the engineering failures, financial disasters, and massive cover-ups behind the world's most troubled mega-projects. Hit subscribe so you don't miss what's coming. In the hyper-accelerated world of Dubai real estate, the marina and downtown skylines became playgrounds for absolute structural hubris. Developers weren't just building towers, they were bending physics on reclaimed sand and unstable coastlines. What began as a race for height transformed into a localized crisis of extreme geometry. This specific project attracted massive institutional and media attention. This was not just a taller version of a standard skyscraper. It was an aggressive rethinking of residential density. The architect created a stark, precise concept, an ultra-thin column of concrete and specialized glass, rising over 1,400 feet above the Persian Gulf. At that extreme height and razor-thin width, the building's slenderness ratio hit an unprecedented 1:15. No residential skyscraper in history had ever been engineered that thin on a foundation, surrounded by shifting desert terrain and intense marine salinity. The combined sellout value approached $1.4 billion, marketed heavily to global billionaires as the ultimate trophy asset. But the physics of the desert had other plans. Today, we break down how extreme thermal expansion, intense wind vortexes, and a catastrophic foundation oversight turned an architectural dream into a multi-million-dollar nightmare. The marketing promised a revolution. The reality is a structural warning sign visible from 30 miles away. The engineering timeline of this $1.4 billion marina mega tower reveals a series of critical miscalculations where theoretical physics collided with the harsh realities of the Arabian desert. Construction kicked off in 2012, fueled by aggressive deadlines and relentless marketing. The blueprint was a marvel of modern engineering, designed to push concrete to its absolute limits. But in Dubai, you aren't just fighting gravity. You are fighting a brutal combination of extreme thermal expansion, shifting coastal sand, and aerodynamic turbulence. By 2015, the structural core had topped out. To combat the severe wind forces at 1,400 feet, where the building faced intense, localized pressure differentials, the design team implemented open mechanical floors every 12 stories. These structural voids were meant to let high-velocity winds pass directly through the building, disrupting what engineers call Kármán vortex shedding, the rhythmic tearing wind cycles that cause super-tall towers to sway violently. In computer simulations and wind tunnel tests, this aerodynamic fix performed beautifully. But the digital models missed the environmental volatility of the UAE coastline. In the desert heat, temperatures fluctuate wildly. The tower's exterior glass and steel framework absorbed intense solar radiation, expanding rapidly during the day and contracting at night. This extreme thermal cycling placed immense stress on the structural joints. Worse, the open mechanical floors exposed the building's internal plumbing, high-voltage electrical conduits, and heavy HVAC infrastructure directly to the corrosive, salt-heavy marine air of the Persian Gulf. By 2017, the first structural warnings materialized. Residents who had shelled out up to $80 million for upper-floor penthouses began documenting deep, metallic groaning sounds and severe structural cracking along partition walls during high-wind events. The aerodynamic voids were successfully bleeding off wind pressure, but the cost was catastrophic. The open-air levels acted as massive thermal shorts, causing localized concrete fatigue. Pipes began fracturing under the strain of continuous building displacement. The very engineering system designed to stabilize the tower was actively accelerating its physical degradation. To understand how rare and dangerous this situation is, look at the architectural parallels across Dubai. In the race to dominate the skyline, other super-tall towers have encountered similar forces, but with completely different engineering outcomes. Look at the iconic Burj Khalifa or the massive residential complexes in Dubai Marina. Standard practice dictates that as a building pushes past 1,000 feet, Its base must expand to distribute the load across the underlying bedrock, anchoring the structure safely into the ground. But this specific pencil tower rejected that safety margin entirely. While legendary skyscrapers rely on a wide, stepping-back geometry to break up wind patterns organically, this building remained an unyielding 115 glass needle from base to crown. This extreme geometry created a terrifying phenomenon known as glass fatigue. Because the tower lacks a tapering profile to deflect aerodynamic forces, the exterior glass panels take the brunt of the atmospheric pressure. As high-velocity winds strike the flat surfaces, the structure sways up to 5 feet at its apex, causing the structural sealants around the windows to stretch, warple, and fail. When the local municipal building code was drafted, regulators were thinking about traditional, high-mass concrete blocks, not flexible glass needles. The code enforces strict safety thresholds to prevent a building from collapsing entirely, but it contains zero guidelines for internal human comfort or structural sway limits. A tower can perfectly satisfy every legal safety code while simultaneously being completely unlivable for the people inside it. Worse yet is the threat from below. Across Dubai's premium waterfront districts, Madash towers sit on reclaimed sand and high salinity water tables. When a super slender building sways continuously, it exerts asymmetric, cyclical pressure on its deep concrete piles. Over time, this movement risks initiating a process called differential settlement, where one side of the foundation sinks into the shifting sand faster than the other. The structural engineers prioritized stopping the wind from knocking the building down, but in doing so, they created a mechanical system that slowly degrades the tower from the inside out. Behind the $1.4 billion glittering facade lies a series of deeply unsettling personal accounts from the ultra-wealthy expats who bought into the dream of high-altitude luxury. These weren't naive buyers. They were international executives, oil magnates, and venture capitalists who hired top-tier legal teams and structural experts to vet their investments. Yet, by 2021, the collective complaints culminated in an aggressive, multi-million-dollar lawsuit targeting the development consortium and the architectural firm. The defect log filed in court is a staggering inventory of high-tech failure, listing over 1,500 distinct structural and mechanical faults. The first nightmare scenario hit during a severe winter storm, when high-velocity desert winds slammed into the upper 30 stories. Inside the top-tier units, residents reported a terrifying sequence. The building began to sway so violently that water sloshed out of bathtubs, and the structural joints inside the walls began emitting deafening, metallic pops. As the tower flexed 5 feet off-center, the immense mechanical stress caused the drywall to shear away from the studs, sending fine white powder raining down onto custom Italian marble flooring. Then came the catastrophic flooding. Because the open mechanical floors were directly exposed to the humid, salt-laden marine air, the heavy HVAC and cooling lines suffered rapid, unexpected galvanic corrosion. A primary water main ruptured on an upper level, unleashing thousands of gallons of pressurized water into the building's core. With the building tilting under heavy wind loads, the water didn't just drain away. It surged directly into the main elevator shafts. The delicate electronic guiding systems and braking mechanisms were instantly submerged, knocking out vertical transit for the entire upper half of the tower. For nearly a week, residents who had paid upwards of $30 million for their sky-high sanctuaries were trapped, faced with the grueling reality of climbing dozens of flights of stairs just to reach their front doors. The defense from the developers was clinical. They maintained the building was built exactly to specification and met all regional safety guidelines. But meeting a baseline safety code does not mean a home is livable. As the legal battles raged, the financial fallout hit the resale market like a sledgehammer. Penthouses that once commanded premium, record-breaking sums sat completely empty, hitting the market at devastating 40% discounts. Prospective buyers conducting basic due diligence instantly uncovered the public court filings, detailing the structural movement and systemic water damage. The building's premium reputation evaporated, leaving early investors anchored to a highly volatile, depreciating asset that literally screams whenever the desert wind blows. The long-term future of Dubai's ultra-slender marvel hangs in a precarious balance between continuous engineering patches and unforgiving physics. While the developer's recent remediation program aggressively swapped out corroded plumbing, sealed compromised window joints, and rebuilt water-damaged elevator shafts, these fixes only treat the symptoms. The fundamental engineering flaw, the 1:15 slenderness ratio, is permanently locked into the reinforced concrete core, unlike standard super-tall structures like Taipei 101, which utilize a massive-tuned mass damper to absorb building sway. This tower was never engineered to house a multi-hundred-ton steel pendulum at its apex. Retrofitting a system of that scale into a fully completed, high-altitude residential structure is a logistical and structural impossibility. The building will always sway. The real threat now is empty units and long-term glass fatigue. As high-net-worth investors flee the building's toxic legal reputation, a staggering percentage of the upper floors sit completely dark. In a region where real estate is an aggressive game of status, an empty, whispering glass needle is a commercial death sentence. The intense, unyielding cycle of extreme daytime heat expansion, followed by violent nighttime wind oscillation, means the structural skeleton is under continuous, compounding stress. The fix truly became the failure. The open-air mechanical floors successfully saved the tower from aerodynamic collapse, but they permanently exposed its vital operational organs to a destructive, salt-heavy desert climate. It stands today as a stark monument to architectural pride. Somewhere high above the marina, a lone resident sits in a multi-million-dollar penthouse, watching their walls flex and listening to the structural groans of a building that pushed the limits of the desert sky just a little too far. If you want to understand the terrifying engineering realities behind the world's most expensive failures, hit subscribe. There are more stories like this, and they only get deeper.